Complete the table of values if f of x is x squared. So the top one, we've seen this a lot of times already, and we know how to just square things, so we can just fill that in very quickly. Now here we have f of 2x. So the 2 is directly multiplying the x, so that must be 2x squared. So if we input negative 4, that's going to be negative 8 squared, which is 64. Input negative 3, negative 6 squared is 36. For negative 2 we get negative 4 squared, which is 16. For negative 1 we get negative 2 squared, which is 4. Then this one's obviously going to be 0. 2 lots of 1 are 2, so square that, that's 4. And then the next one will be 16, 36, 64. Then we have f of 0.5x, so that's going to be 0.5 directly multiplied to the x and then squared. So for negative 4, that's going to be negative 2. If we square that, we get 4. Let's do the even ones first because they're easier. So that's going to be negative 1 squared. This one's obviously going to be 0. Half of 2 is 1. Square that, we get 1. Half of 4 is 2. Square that, and we get 4. Now if we substitute in the negative 3, half of that is 1.5, and if we square that, we get 2.25, so that's 2.25. And this one's going to be 0.25. So 0.25 and 2.25. So the blue one here is y equals x squared, a curve we know very, very well. Now, obviously on this scale I can't plot negative 4, 64, nor negative 3, 36. Negative 2, 16 I can do. Negative 1, 4, 0, 0. Then we've got 1, 4, and 2, 16. So those can all go on. And then we just need to try to draw this as well as we can. So like that. And like that. So we have y is equal to 2x all squared. Now, let's change over to the 0.5x. So negative 4, 4. We can put that one on. And negative 2, 1. 0, 0, and 2, 1, and 4, 4. Now I could put those intermediate ones in, 2.25 and so on, but I think I've got enough points here. So that's going to go something like this. And just do the best job we can of drawing it. So something like that. And this one is the 0.5x all squared. Now if I ask you to describe this, you'd probably say it's a vertical dilation, like we've seen with a times f of x. X squared's a really poor example to use for this particular transformation. Because of that, it looks exactly like this. But it's not. The dilation here is actually horizontal. We'll do some examples in a moment that show this better. But if we consider this one's the original curve, what's actually happened is this is squashed in towards the y-axis. We can see it's squashed in on both sides. And if we actually look down here, we can see that the x-coordinate is halved. So for the 2x squared, the x-coordinates are halved and the y-coordinates stay the same. Now, it's halved because that's 1 over 2. So if we look at this one, the same argument, it should be 1 over 0.5, which is equal to 2. Is that the case? Well, if we look here and here, we can see that the x-coordinate is doubled.